Alright, welcome back. So now we're looking at how a tree diagram can be used to help us out with some probability questions where we have ultimately some compound events. So let's get started with our first one. We have our coin toss and we also have our die spin roll. Alright, and our outcome. Now we've done this a bunch of times already, so you should have a really good idea of how to do this. Okay, and then you just draw all of your lines. Alright, there's a little makeshift tree. Our outcomes are H1, H2, H3, H4, H5, and H6, and then T1, T2, T3, T4, T5, and T6. There's our tree diagram. Now we have all our outcomes listed. We have to look at, for B, what is the probability of heads or 3? So probability H or 3. Now remember that OR is inclusive. So that means that we are taking the probability of getting both the probability of getting heads and adding it to the probability of getting 3s. Now, the one distinction we have to make here is that if these two have an intersection or an overlap, we have to take that away. So, starting out, we have our total number of outcomes is 12. But now we need to see how many of these have a heads and how many of these also have a 3. Well, every single one here has a heads, so we can nearly add 6. And then when it comes to our other set, well, we have a T3. That's all we can do. Right? Heads or 3 only includes everything with heads and everything with a 3, and there are no real intersections, so add the 1 on there, and it's 7 out of 12. And now we have find the probability of not a tail with a 2. So probability of not tail and 2. Alright, let's see if I can make that 2 a little bit better. Right, so if it's not a tail and a 2, so we just don't want this. If we don't want that, everything else is possible. That means that the other 11 out of 12 values, that's the probability. So the probability that we don't get that particular outcome is 11 out of 12. Alright, here's another one. So when we're looking at this one, we have the same exact one as before, but we're going to look at it a little bit differently because we're going to look at some compound outcomes. Right, so we have 1, 2, 3, and 4, and then 1, 2, 3, and 4, 1, 2, 3, and 4, and 1, 2, 3, and 4, and then 1, and 2, and 3, and 4. Now, you can see that at a certain point, drawing all these lines is more part of answering the question than helpful. Once you understand how we actually are determining all the possible outcomes, this is a little bit not useful, but later on it will go back to being useful when we consider different weights and different chances that aren't all equal. Alright, so there are all our outcomes done. We can see that we have 16 total outcomes, 4 groups of 4. So total outcomes is 16 total. Now let's look at B. So find the probability. Probability, the first spin is greater than the second spin. First greater than second. So it's something out of 16, but how many of these are favorable events? So in our first group here, 1 is greater than none of them. So all of these guys can go. In our second group, 2 is greater than one of them. In our third group, 3 is greater than 2 of them. In our fourth group, 4 is greater than 3 of them. So we have a total of 6 favorable outcomes out of 16. Our second one, find the probability of at least 1 4. Alright, so the probability of finding at least 1 4. Please ignore what I've written up here. It's just a little shorthand, but if you're doing this in an actual question in a test or something important, write out exactly what's written here. Okay, so at least 1 4. Well, how many outcomes have at least 1 4? Well, there's 1 there, there's 1 there, there's 1 there, and then there's this entire group down here. So we have the 4 down the bottom, 5, 6, and 7 out of the 16 outcomes have at least 1 4. So you can see drawing this helps us determine a lot of these more complex compound or combined events that would be a little bit more annoying to think about just in terms of the numbers alone. Alright, that's it for this video. Hopefully it's helpful, and I will see you in the next one.